Equations and identities. What is an equation? How is it different than an identity? Discuss in your groups. Think of what those words mean to you. Where have you seen them before? Where have they come up in your prior math courses? What would be their definitions? An equation is created when two expressions are set equal to one another, such that they are equal for some values of their variables, but not for all. If they are equal for all values of their variables, then that is an identity, not an equation. There's your difference. So not all mathematical statements which include an equal sign are equations. Some are identities. Here are some examples of identities. We have 2 plus 3 equals 5. So see the same thing, 5 and 5 on both the left and right side. 9 minus 2 equals 7. 5 times the quantity x minus 3 equals 5x minus 15. And 0.5y equals y divided by 2. These are always true, whether there's variables or not. But if there are variables, there are no values that can be assigned to the variables for which they would be untrue. They are always true. They are both equal always on both sides of the equal sign. Now here are some equations. So we have s equals 15 over t, v equals 12 minus 9.8t, x equals 10 plus 6t minus 4.9t squared. In all of these cases, the variables are interdependent. They are only true for certain sets of variables. Changing the value of t on the right side of the equation changes the possible values of s, v, or x on the left side and vice versa. And again, so these are equations, not identities, since knowing the value of one variable changes the possible value or values of the others. Above are simplified physics equations in which t represents time, s represents speed, and v is for the final velocity, and x is for the final position. In these equations, we only have two variables, but in later math courses, there will be more than two. For instance, here are some more general versions of those same equations. So here we have s equals d over t. Here we have v equals v sub 0 plus a times t. X equals x sub 0 plus v sub 0 times t plus 1 over 2 or 1/2 a times t squared. In these cases, there are up to 5 variables. These are much more complicated equations, which all depend on each other. So you'll work more with these in Algebra 1, but it's important to see that equations define the relationship between variables, since the equation is only true for certain sets of values, right? They're not identities, they're equations. So now let's use this table to find some solutions to the equation s equals d over t. And here, s is going to represent speed, d represents distance, and then t represents time. And we're using the units of meters and seconds. So speed is meters per second, distance is in meters, and t is in time. And if you see, we're using a table because it's nice and neat. It organizes all of your values, and you can see between each row when you change the values what the different values of s are going to be, how it affects the value of s. So we've entered the distance traveled and the time it took to travel that distance in two of the columns, right? The first column we have the distance measured in meters, and the second column we have it time in seconds. So we're going to use the equation s equals d over t. We're going to divide the values to find the speeds and fill in the blank column. So here, we've filled in the third column. We've taken that equation s equals d over t and we've divided. So for example, the first row we took 30 over 2. The third row, 90 over 6, 120 over 2. We took the first row and divided it by this, or the first column, the distance, and divided it by the second column, the time, to get and fill in those values for speed. So note, in the first three sets of answers, the object was moving at a speed of 15 meters per second, and the final three sets of answers, are for an object traveling 4 times faster at 60 meters per second. But in all cases, you have to know the value of 2 of the 3 variables to determine the value of the third. Again, that's really important because then you can kind of play around with your table. It doesn't always have to be a missing value in this equation, let's say, of speed, but you can work backwards as long as you know 2 of the values. Knowing any of the 2 values, you can determine the third. So try it in this case. Again, we're still using speed equals distance over time, but now the values of different variables are provided. Again, it's not always the first 2 columns, but we have missing values all over the table. Can we still figure out the unknown values? Yes, because we still have 2 for each row. We have 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So we should be able to plug that into the equation and solve for the missing value. So here we've done just that, right? This was more challenging since the equation is solved for S, not D over T. So we had here this third column. This one was a straightforward one. This one we can do 20 divided by 2. But as soon as you get to the second row, right, the first row versus the second row, now you're missing that value of D. So you would have to plug in the speed is 10, and that equals something D over 5. So not 10, actually the second row is 20. Given 20, I was looking at the first row. But here, so we have 20 equals D over 5, so you would have to multiply both sides by 5. That's how you get 100. Even here, you have a distance of 100, but then you're told the speed. So that would be 10. So that you would have to substitute in 10 equals 100 divided by the time. So that's how you're getting 10. This definitely is more challenging. Filling in the values will be even more challenging when we work with more equations that have more variables. So we always need a way to solve an equation for any variable so that we can find its value given the values of the others. Solving an equation for a variable means getting it alone on the left side of the equation. That will be more helpful than trying to, again, work through which variable do you have, substituting it in, solving for different variables. If you solve an equation for a variable, getting it alone on the left side, then it will always be easier to substitute in values and find the missing one. So a table is helpful to organize, but solving an equation will be even better for a specific variable. It will be more helpful in the future.